following content is provided under WISA mechanism group.
So the problem we have basically asks us to find out how many different combinations of 4-person member committees can be formed from this 110-member committee. So the first thing we need to realize is the total number of people in this committee, N, is actually 10. And then we're looking at forming subcommittees comprised of 4 different people. So our K value is 4 because we're trying to choose, from the 10 we're trying to choose 4 people to make up our small subcommittees. So what does this tell us? It doesn't really matter the kind of order you will take to form these small subcommittees out of the 10-member club. So we know that, let's assume that these 4 people are Anne, Dev, Peter, and Wissam. So if I'm to choose these 4 people to join my small subcommittee, it doesn't really matter which person I choose first. All I'm interested in is the 4 people in that subcommittee. It doesn't really matter if I chose Anne first, then followed by Dev, Peter, or Wissam, or if I did it the reverse way, choosing Wissam first, Peter, Dev, then Anne. Or probably interchange them, choosing Dev first, followed by Anne, followed by Peter, followed by Wissam. It doesn't really matter. So in this kind of problem, the order doesn't really matter. And secondly, you're basically sampling with replacement. So we are saying a total sample space of 10 members from which you need to form 4-person member subcommittees. So this is basically a combination because the order really doesn't matter. I'm just saying that we have 10, and from the 10 we need to choose only 4. This is the formula we could use, which is 10 choose 4. And this formula can as well be written as 10 choose 4. That is the formula we're basically going to look at using. So we're saying the general formula would be written as n choose k, in which we have n factorial over n minus k factorial n factorial. So we're having n being our total number of people we're choosing from, which is 10, k being the total number of people wanted each subcommittee, and that is 4, and then n minus k is basically giving us the people we don't want to choose, that is 6. So we'll have 10 factorial over 10 minus 4 factorial, 4 factorial. And this is going to give us 10 factorial over 6 factorial, 4 factorial. This will lead us to 10 by 9 by 8 by 7 by 6 factorial over 6 factorial, 4 factorial. So right here we can just cancel out the 6 factorial, both on the numerator and denominator. Then we are left with 10 by 9, which is 90. 8 by 7 is 56. So 9 times 56 should be able to get our product there divided by the 4 factorial. So by making this computation, we are able to come up with 90 by 56 divided by 4 factorial. And this is giving us 210. So basically, this is telling us that there are 210 different combinations that we could have out of the 10-member club that will allow us to form different subcommittees. So we could have 210 different subcommittees comprised of 4 people. So that is one way we could probably look at solving this problem in a very short and precise way. And